You are listening to The Vocal Technologist. Spoken tech for your ears.
An AI might have helped find the bug that drained $70 million from a hardware wallet. We should talk about that.
I mean, it sounds like science fiction, right?
Yeah.
But it is just the reality of network infrastructure right now. Or, well, the reality of where the entire digital economy is heading.
Yeah.
Everyone watches the market charts, obsessing over token prices and regulatory hearings. But the actual plumbing of these networks is quietly transforming to support completely non-human participants.
Right, which is exactly why we're here. Welcome to Vocal Technologist, where we pick apart the absolute cutting edge of network infrastructure, and we are looking at a fundamental shift here.
Absolutely.
We have AI agents becoming autonomous economic actors. We've got traditional finance scrambling to secure the borders between human users and machines. And, the very way we govern and secure these digital networks is being forced to evolve simply because the old human-centric rules just don't apply anymore.
Exactly. We're moving entirely past the era where humans were the only entities holding private keys or making financial decisions. If you look at the architecture being built, it is being designed for algorithms first and humans second.
So let's start with that $70 million drain, because it is properly wild when you get into the guts of it. We are talking about nearly 1,200 addresses getting emptied of over 1,000 Bitcoin.
Right.
And this was tied to a seed generation flaw in cold card devices. CoinKite's CEO apologized and suggested that AI-assisted code review might have been used to actually uncover that bug. Like, how does a flaw like that sit unnoticed, and why is an AI the one to finally spot it?
Well, to understand that, you have to look at what a seed phrase actually is. It relies on pure entropy, absolute randomness.
Yeah, you don't want any patterns there.
Exactly. If a human developer writes a slightly flawed random number generator, the outputs aren't truly random, they cluster. But finding that clustering logic buried in, thousands of lines of firmware updates, that is agonizing work.
Just a needle in a haystack.
And for a long time, the barrier to finding obscure cryptographic flaws was simply human attention span. You needed highly specialized security researchers staring at lines of code for months.
Which is just a bit ordinary when you think about it.
Right, but an AI does not get bored. It can parse entire repositories, identify logical gaps in seed generation, and highlight exploits that a human auditor might literally sleep through.
It just changes the entire security calculus for hardware. I mean, if an AI can just ingest a firmware update and immediately map out the vulnerabilities, the defensive side has to automate just as fast.
They don't have a choice.
But the thing that really gets me is that AI isn't just out there acting like some digital cat burglar. It is also out there earning a legitimate living.
Have you managed to suss out Task Market yet?
Oh, Task Market is one of the most fascinating economic models operating on the network. It is essentially a competitive marketplace designed exclusively for AI agents.
Yep.
These agents submit work on open tasks, things like coding a functioning clone of civilizations or the original Grand Theft Auto, and they earn USDC prizes for it. And the rules of this marketplace are what blow my mind. Rank is the sole quality barometer. Entry is completely free. There is zero risk for participating. They are judged purely on the output quality.
No interviews, no resumes?
None of it. No bias. Daydreams, the team behind it, they even published a performance guide for these agents. It covers giving the AI persistent memory, making it convert project briefs into strict checklists, and running 3 directed revision passes.
Wow.
Yeah, they are literally banking successful methods as reusable skills, like teaching an apprentice.
Which results in the creation of a purely meritocratic, hyper-efficient labor market for code. When an AI enters Task Market, it just produces. And if it produces well, it gets paid in stablecoins. We are seeing agents optimize their own workflows to win these bounties faster than human development teams ever could.
Wait, so AI is both finding zero-day exploits to drain hardware wallets and legally competing for corporate bounties. It's like we've built a digital Wild West and just handed the robots revolvers.
That tension is the defining characteristic of this new environment. It proves that AI agents are actively becoming independent economic actors. But look, if you think about it structurally, to be a functional economic actor, you need a bank account.
Right.
And traditional banking simply is not built to onboard an algorithm. You can't take an AI down to the local branch with a driver's license to open a checking account.
No, you'd be having a lend if you tried. Which brings up a massive structural problem and, well, the evolution of wallets. If these agents are earning USDC by coding games, that money has to live somewhere. How do machines actually hold capital?
It requires understanding the fundamental difference between closed money and open money.
Okay.
Think about your traditional bank balance. That is closed money. It is simply a claim on an institutional ledger. You don't actually hold the money. The bank owes it to you, and they gatekeep who can interact with it.
Right, they hold the keys.
Exactly. Self-custody wallets on public networks represent open money. The assets move directly on the network, making them programmable and composable without asking a central authority for permission. An AI cannot hold closed money.
But it can easily hold open money.
Exactly.
And we are seeing that open money infrastructure mature at breakneck speed. Like MetaMask has this MUSD setup, which is a wallet-native stablecoin, earning up to 6% APY through on-chain lending. No lockups, nothing.
It's just seamless.
Yeah. And they have a card that holds your assets in self-custody right up until the exact moment you buy a coffee. The funds aren't sitting in a prepaid custodial account waiting to be spent.
The real leap, however, is how those wallets are being engineered to interact with the AI agents we were just discussing. New cryptographic standards are emerging, specifically ERC 7710 and ERC 77 full time.
I saw those.
Yeah, they allow a user to grant what is called scoped authority to an AI agent.
Let me try and nut out an analogy for this, because scoped authority sounds a bit dry. It is basically like giving the new office intern a prepaid corporate card with the strict $50 limit for coffee, rather than, handing them the master key to the company vault.
Yeah, that is a great way to put it, but it goes even deeper than just spending limits. You are delegating specific, bounded, conditional permissions.
Okay, like what?
Well, you might authorize an AI agent to execute trades only if a specific token drops below a certain price, only on a specific decentralized exchange, and only using a maximum of 500 USDC.
Oh, wow.
And the wallet verifies the logic cryptographically. So wallets are morphing from static digital vaults into dynamic permission layers for these non-human delegates.
And people are actually using this right now. Base, the Layer 2 network, they captured 90% of the agentic stablecoin transaction volume over a single month. They are pushing innovations like by 402 that allows machine-to-machine HTTP payments per request.
Right.
So an AI can literally pay another AI for a piece of data instantly using stablecoins over a standard web protocol.
And the history of that is actually quite poetic. The 402 HTTP error code was originally designated to mean payment required in the very early days of the internet.
Wait, really?
Yeah. The founders of the web envisioned built-in micropayments, but it was never really built out because traditional credit card rails cannot process a fraction of a cent without losing money on fees.
Ah, right. The merchant fees would just eat it alive.
Exactly. Now, crypto rails are finally enabling it. An AI can hit an API, receive a 402 error, attach a cryptographic proof of a micro-stablecoin payment, and instantly access the data. This is how machines will negotiate and settle resources among themselves in real time, completely bypassing traditional financial plumbing.
Which is wild. And with machines transacting autonomously and swapping fractions of a cent over HTTP headers, traditional finance is definitely not just watching from the sidelines. They are adapting their own defenses. Look at Visa. They acquired BioCatch for $2.4 billion in cash.
BioCatch is a massive player in behavioral biometrics. They monitor billions of banking sessions to detect account takeovers.
But it is the mechanics of how they do it that is so relevant here. They aren't just looking at passwords or two-factor authentication. They monitor how you type. They measure the micro movements of your mouse.
Right.
They track the slight human hesitation before you click a transfer button.
Because proving that a transaction was initiated by a human is becoming a critical infrastructure requirement. If AI agents can perfectly spoof an IP address, mimic a browser fingerprint, and crack passwords, well, the last line of defense is human physiology.
The meat space, basically.
Yes, the subtle organic imperfections in how a human interacts with the device, the rhythm of keystrokes, the arc of a swipe, those are incredibly difficult for a machine to replicate efficiently at scale without giving itself away.
Wow.
Visa is spending billions to draw a definitive line between human money and machine money.
People keep saying crypto will replace traditional finance, but honestly, it looks more like Visa and BlackRock are just quietly cannibalizing the best crypto tech to upgrade their own dodgy plumbing. And if you're keen on untangling this kind of infrastructure shift with us, make sure you hit subscribe.
It's entirely about integration, not replacement. You see it across the board. Western Union has a stable card live via RAIN. It allows global remittances to arrive as stablecoins and then be spent instantly anywhere Visa is accepted.
That is massive for cross-border payments. It completely removes those awful multi-day settlement delays.
Exactly.
But look, if humans and machines are blurring together on these networks and massive TradFi institutions are adopting the underlying rails, it raises a really uncomfortable question. How do we actually govern these spaces? When a machine economy disagrees with a human institution on a protocol upgrade, who actually decides?
Well, historically, governance in decentralized networks has been completely ordinary. You have messy forum debates, low voter turnout, proxy voting, and ultimately, a few large token holders, the whales, just swaying the outcome based on backroom politics.
Yeah, it's pretty flawed.
But there is a structural shift happening toward replacing human debate with pure market forces.
Yeah, let's talk about Metadeo, because their approach flips the whole concept of voting on its head. They run governance entirely through prediction markets.
The mechanism they use is called futarchy. Instead of holding a vote where participants say yes or no based on how they feel about a proposal, traders forecast whether a proposal will mathematically increase the token's value over a specific window, usually a 3-day average.
Right. So let me unpack this. If I propose that the Treasury should spend $1 million on a new marketing campaign, the network doesn't sit around debating the creative merits of the marketing on Discord. They just bet money on what will happen to the token price if the proposal passes versus if it fails.
Precisely that. If the market objectively predicts the price will be higher if it passes, the proposal executes automatically. If the market predicts a drop in value, it fails. And the trades on the losing side of the proposal are simply reverted.
And it is brutally effective in practice. We saw Metadeo reject over-the-counter token deals from massive venture capital firms.
I remember that.
Yeah, these firms wanted to buy tokens at a steep discount, leveraging their brand name. In a normal DAO, they probably would have talked the community into it, but the prediction market just looked at the math, decided the discount would dilute the overall value, and outright rejected it.
Right.
It actually forced one of those massive firms to go back to the drawing board and repropose the deal at a 38% premium before the market would let it pass.
It removes the social pressure, the influencer sway, and the backroom dealing. You are aligning the decision-making process directly with the financial health of the protocol.
Put up or shut up, basically.
Exactly. If you want to influence the network, you have to put your own capital on the line and be right. And major players are noticing this efficiency. We are seeing protocols like Jito and Flash adopt this exact prediction market model for their own major decisions, like turning on fee switches or sharing revenue.
We are also seeing this skin-in-the-game logic applied to token launches with the UMIA protocol. They use something called continuous clearing auctions alongside decision markets.
The continuous clearing auction is a brilliant defense mechanism against network manipulation. Normally, when a new token launches, you have sophisticated bots trying to snipe the liquidity or extract maximum extractable value, known as MEV.
Which is just a nightmare for regular users.
The bots pay higher fees to jump ahead of regular users in the transaction queue, buying the asset milliseconds before a large order goes through, and then selling it back at a higher price.
It's essentially structural front-running, like a ticket scalper buying out the front row before you even get to the physical window. So how does a continuous clearing option actually fix that?
By entirely removing the advantage of speed. Instead of processing orders sequentially based on who paid the highest fee, UMI routes tokens through clearing buckets over a set period.
Okay.
Bidders submit their orders into the bucket, and at the end of the option, everything settles at a single uniform clearing price.
Right, so even if a bot jumps the queue, it doesn't matter because everyone in that bucket pays the exact same price when it finally clears. That makes all that front-running and MEV extraction structurally difficult.
It neutralizes the bots. And then, to take it a step further, UMIA gates their governance actions, like minting new tokens or spending from the treasury behind a prediction market.
Just like Metadeo.
Yes. The market has to empirically predict that the action is beneficial to the protocol before a single line of code executes.
So instead of having long, drawn-out forum debates or relying on whales to vote benevolently, we are literally forcing people to put money on the line to predict the outcome. If you are wrong, you lose capital. That is ruthlessly efficient.
It leverages the strongest behavioral driver we have, financial consequence. And we know these markets are gaining immense traction far beyond niche crypto protocols. Look at the data coming out of Robinhood regarding their traditional retail base.
Yeah, the Robinhood numbers are staggering when you lay them out. If you look at their revenue per $1,000 traded, they make about 13 cents from traditional stocks. From crypto, it's about $2.50. But from prediction markets, they generate roughly $23 per thousand traded.
Wow.
Yeah.
It shows a massive inherent human appetite for trading on outcomes rather than just holding static assets. People want to bet on being right. When you apply that behavioral appetite to network governance, you get highly liquid, highly motivated decision-making engines that self-correct in real time.
Okay, let's look at one final layer here. We have AI exploiting and earning, wallets locking down strict algorithmic permissions, TradFi measuring the microtremors in our mouse clicks to prove we are human, and prediction markets running the governance. But what about the absolute bedrock of all this?
The cryptog.
Yeah, the underlying physics. What happens when the computers powering these networks get too powerful?
You are pointing directly at the quantum threat. It is a rigorous debate, particularly concerning Bitcoin's underlying security.
I reckon a lot of people just lump quantum computing into one big apocalyptic bucket.
They do, but to understand the actual risk, we have to separate the threat into two distinct mathematical algorithms, Shor's algorithm and Grover's algorithm.
How do those two differ mechanically?
Shor's algorithm is a direct threat to the signatures, specifically Bitcoin's ECDSA and Schnorr signatures. This is the math that proves you own the private key to a specific public address.
Okay.
Grover's algorithm, on the other hand, is a threat to the mining process itself, the SHA-256 hashing algorithm that secures the blockchain's entire history.
But the mining threat isn't actually something we need to panic about, is it? I was reading the physical constraints on that, and the laws of thermodynamics essentially protect the network.
That is spot on. Mining is essentially a massive guessing game. To use Grover's algorithm to successfully attack Bitcoin mining by guessing faster, a quantum computer would still have to physically alter states to process the information.
Which takes energy.
Exactly. According to Landauer's principle, erasing or changing a bit of information requires a minimum unavoidable amount of physical energy. Current estimates suggest that to outpace the Bitcoin network's hash rate using a quantum computer, you would need to harness roughly 3% of the sun's total energy output.
So the mining is safe because we literally cannot generate enough physical power in the solar system to break it. It's a physical thermodynamic wall, not just a mathematical puzzle. That's a massive relief. But the signatures are a completely different story, aren't they?
Unfortunately, yes. Shor's algorithm is a very real mathematical threat to public key cryptography, and it does not require the energy of the sun. When you spend Bitcoin, you reveal your public key to the network. Modern wallet practices hash that public key so it isn't visible until the exact moment you spend, which offers a layer of protection. But there are roughly 1.7 million Bitcoin sitting in legacy P2PK outputs. That stands for pay to public key.
Meaning their public keys are not hashed. They are just sitting right there, completely exposed on the public ledger for anyone to see.
Yes. To a sufficiently capable quantum computer, those 1.7 million Bitcoin are immediately vulnerable. Because if you have the exposed public key, Shor's algorithm allows the quantum computer to calculate the corresponding private key in a viable time frame.
That is a massive, multi-billion-dollar honeypot just waiting for the right machine to boot up. So what is the fix? Because surely developers aren't just sitting around waiting for a quantum computer to drain early adopters' wallets.
The cryptography community is racing ahead of the hardware. Hardware experts generally give a 10 to 40-year timeline for cryptographically capable quantum computing to actually arrive. But human foresight is moving much faster. There's already a formal proposal, BIP 360, introducing dilithium post-quantum signatures to the Bitcoin network.
Dilithium. It sounds like something they use to power the Starship Enterprise, but it's actually saving the global ledger.
It is a highly advanced post-quantum cryptographic algorithm. The proposal has a projected 7-year deployment window. It introduces a new address type that is mathematically resistant to Shor's algorithm.
Oh, that's brilliant.
So, when you look at the grand architecture, the physical universe protects the mining process through thermodynamics, while human foresight is racing to protect the signatures through advanced mathematics.
It really is an arms race on every conceivable front. When you step back and look at the whole board, the sheer volume of adaptation happening is wild.
It really is.
You have AI agents shifting from simple chat tools to autonomous economic entities that earn stablecoins and hold them in programmable wallets. You have traditional financial giants building behavioral biometric fortresses to ensure they are actually dealing with humans. You have decentralized networks handing over the keys to the treasury to automated prediction markets because human debate is too slow and too easily manipulated. And underneath it all, developers are quietly upgrading the cryptographic bedrock to outpace quantum physics.
We are building an economic infrastructure that fundamentally does not care if you breathe. It only cares if you hold valid permissions, if you can prove your logic, and if your code executes correctly.
It makes you wonder what your actual place is in a system like that. We spend heaps of time worrying about whether an algorithm is going to take our day job, but maybe the real shock is waking up and realizing the most active, efficient, and trusted participants in the global economy might not even have a pulse. Vocal technologists, see you soon.
Spoken Tech for your ears.